So we'll expand this with another example. What are the best predictors of safety precautions? And we'll use 4 predictor variables in this instance: general anxiety, fear of crime, and we'll add 2 more: learning from a friend's victimization and the importance of social bonds. And in this instance, we'll use what we refer to as a stepwise multiple regression. This is where variables are entered one by one into the regression equation rather than having all 4 variables entered at the exact same time. And so the output boxes will change a bit, but the interpretation of the values is the same. So in this instance, we see a model summary with 4 models presented. Notice the subscripts below the table. It tells which predictors are included in that model. So notice model 1 only has fear of crime. Model 2 has fear of crime and learning from friends victimization. The third model has both of those and adds social bonding. And the fourth model has all 3 of those and adds general anxiety. So let's draw the attention to the fourth model that includes all 4 variables. The R-square value is 0.204. So the model explains 20.4% of the variability in the dependent variable, in this case, safety precautions. Also notice that the F value is significant. In this instance, as we move from model 1 to model 4, what we're looking for is significant change. And so in the first model with 1 predictor, we only explained 12.3% of the variance in the dependent variable. But as we moved through adding new predictors, we ended up with the fourth model that explained 20.4%. And so this is a significant change from step 1 to step 2 to step 3 to step 4. And so had there been no significant change, no further variables would have been added. But in this case, the addition of 1 variable at a time improved the model, improved the prediction or the variability that was accounted for by the model. So notice here, I just want to draw your attention down to the fourth model that includes all 4 predictor variables. And notice that the beta coefficients are in red, and that fear of crime has the largest beta, learning from friends victimization the second, social bonding has the 3rd largest beta, and then general anxiety has the 4th largest beta. Also note the probability values for each. All 4 variables in this equation or in this model are significant, so they all contribute to the explanation of general safety precautions. In some instances, when you add variables to a regression, some may not be significant, which is important to know, especially if they had a significant relationship at the bivariate level. But when you include them with other control variables or other predictors and they're no longer significant, that's important to know. Also note the partial correlations here. Notice that the partial correlation coefficients don't necessarily align exactly in the same order as the beta coefficients, which is perfectly fine. So in this model, we would suggest that the fear of crime has the greatest amount of impact or effect in predicting general safety precautions, as a 1 standard deviation increase in fear of crime increases the number of safety precautions taken by 0.208 standard deviations. Right, so because of partial correlation is an indirect PRE, to account for how much variance is explained by this, we would need to square the partial correlation. So that results in a 0.021316 value. So fear of crime explains roughly 2.14% of the change in general safety precautions. On the other hand, the variable with the largest partial R is learning from friends victimization, with a 0.202 partial correlation, which results in a 4.08% R-square or partial R-square value. So it explains roughly 4% of the change in general safety precautions. But again, customs suggest we look at the beta coefficient to determine which variable has the greatest impact on the dependent variable.